Hi friends, welcome to Unacademy, India's largest learning and teaching platform. Myself Bhavani. Unacademy offers plus courses for Karnataka CET students. Students who want to excel in the CET, Karnataka CET exam in the year 2021 can subscribe the plus courses. When you join a plus course, what are the benefits, what are the benefits you are going to get? So students, am I audible? Those are listening. Am I audible, student? So Unacademy, if you join the Unacademy, both class 11 and class 12 topics will be done in detail. You will be given all the tips and tricks to share the problems to arrive at the answers very quickly. There will be practice paper and full-length mock tests with analysis. Educators will be taking different classes, so you will, but then unlimited access. So whichever will appropriate that batch you can join. We have a comprehensive batch. You can join this batch. We also have a 6-month batch, which is a Kannada batch. In case if you are comfortable with Kannada, you can, join this batch also. There is a 12 months plan at the rate of 12,375. There is a 6-month plan at the rate of 10,125. Students, in case if you are joining these batches, kindly make use of the code Bhavani Live and see to it that you are getting the maximum discount associated with this code. There is a champions batch also, students, so which has been started from October. So you can be a part of this batch also. PCM, PCMB, PCB. So you can join any one of these batches. There will be, free practice tests. So want to have a very good practice, once you study a topic, you will have a free practice test. Kindly enroll your name for the test and with all the, concept, after learning the concept, not before learning. You have to attempt it live and see to it that before you face the KCET exam, you will be actually writing as practice test possible. So today, students, we test on the solid state. You see in class 12, you have the first topic, the solid state. So we will have, some of the important questions, solving from this chapter, the solid state. It is one of the easiest chapter. You can think of solving the question, and most of the questions are, easily answerable, student. So directly now we will go back to the question one by one. Meanwhile, student, do not forget to, subscribe the YouTube channel also. And if you haven't watched my previous YouTube session, kindly watch them. And also, whenever you like the video, kindly press the like button. So do not forget to like, share, and subscribe. So we have question number 1. The contribution of a particle at the edge center to a particular unit cell is option A 1, option B is half, option C is 1 by 8 and option D is 1 by 4. So students, the contribution of a particle at the edge center. So if at all a particle is at the edge center, what is its contribution? Suppose if you think it's a unit cell, look here now, this is a unit cell. If you have a particle which is inside the cube, then it is not shared by any unit cell, so its contribution is 1. If a particle is corner of the unit cell, then it is shared by, you can see, 8 unit cell. 1 on this side, 2 here, 3 here, 4 here, above this 5, okay. So 6, you can see here if you want, you take this as a cube, student, take this as a corner, correct. So you can see this red particle, what you see here, is shared by how many unit cell? 1, 2, 3, 4, 5, the other side 6, 7, 8. So whenever a particle is at the corner, student, it is shared by 1 by 8. Its contribution is 1 by 8 towards the unit cell. If a particle is present at the face center like this, so half of it will be inside this cube, half of it will be, here on the other unit cell. That means each unit cell is getting a share of 1 by 2. Now the question is about a particle which is at the edge center. If it is at the edge center. So if it is at the edge center, you have a unit cell here. So this particle is shared by this unit cell also. Similarly, you have a particle above, right? You have a unit cell above and you have a unit cell above. So this particle which is at the corner, which is at the edge center, is shared by 4 unit cell. I hope I am making it clear. If you have a particle at the edge center, it is shared by, student, 1 on this side, 1 on this side. You have 1 more unit cell above, 1 more unit cell on this side above. So 4 unit cells are sharing it. That means the share is 1 by 4. You can take here also that example, thinking that this is the entire edge. If you take, okay, you can think this is the edge center. So it is shared by 1 unit cell. Okay, it will be shared by 1 unit cell, 2 unit cell, 1 more above and 1 more on this side. So 4. So students, the contribution is 1 by 4. So what will be your answer? Your answer is option D. So one answer for option A will be the answer if it is inside the cube. Option B will be the answer if a particle is at the face center. Option C will be the answer if a particle is at the corner of a cube. So if it is at the edge center, then the option 1 by 4 is the right answer. Okay, go to the second question. Look here, student. Which of the following crystal has unit cell such as A is not equal to B, B is not equal to C, and alpha is not equal to beta, not equal to gamma, not equal to 90 degree. Students, this question has been asked in CET 2017. So you remember that when you are studying, in NCERT textbook, a clear table is given where 7 crystal systems are explained with their actual length and with their actual angle. With their actual length and with their actual angles. Correct, student? Okay. So there are 7 crystal system given. In that, the system what is given here is surely a triclinic system. Because in a triclinic system, none of the sides are equal, none of the angles are equal, and they are not equal to 90 degree also. That means when you prepare yourself for a CET exam, students, the table what is given in your book, you need to be knowing. Now, this time the question was about triclinic, but it need not be triclinic every time, isn't it? It can be, for other system also. Therefore, you should be thorough with this table. You can make your own way of remembering it, okay? there are different ways in which you can remember actually. So students, if you can remember, if you see here, there are two systems where the sides are not equal. See, so you can make it together and study. It's up to you. See, orthorhombic you can see, and also monoclinic. Can you see? Orthorhombic and monoclinic. A is not equal to B, B is not equal to C. Here also it is same, and also for triclinic. These sides are not equal. Okay. You have tetragonal system where A is equal to B but B is not equal to C. And the same system is for hexagonal also. Kindly see. A is equal to B, B is not equal to C. Here also A is equal to B, B is not equal to C. What we have mentioned, they are, same condition. Whereas for cube, I hope I'm audible, students. So as you can see, since this is a condition given, as you can see, potassium dichromate comes under triclinic system, student. Therefore, the answer for A is not equal to B, B is not equal to C, and alpha is not equal to beta, beta is not equal to gamma, not equal to 90 is an example where potassium dichromate crystal has the same triclinic system. So answer will be, student, option B, student. Okay. Whereas sodium nitrate is a trigonal system. Potassium nitrate also, you can see is potassium nitrate here. Orthorhombic system. Okay. KNO3 is an orthorhombic system. K2SO4 is also orthorhombic system. So the only answer is potassium dichromate. Do not prepare only for this question. Similar question, thinking that any one of these can be asked. So kindly remember this entire table with the example. Okay, we'll go for the next one. The correct statement regarding defect in solid is. The correct statement regarding defect in solid is. Option A, trapping of proto in the lattice leads to the formation of F center. Students, you all know that it is not trapping of photo in the lattice leads to the formation. It is the electrons which are trapped in the lattices will absorb energy from the light, and they are responsible for F center. So this is not the right one. Frankel defect is a dislocation defect. Now, Frankel defect, is it a dislocation defect? What is Frankel defect, student? Frankel defect means, suppose if you take a crystal system like this, okay? Suppose if you think this is a crystal system, you will have maybe, see, this is plus, you think this is positive ion, this is negative ion. The cations are missing from their lattice position and they will move to the interstitial site. Or in other words, the cations are dislocated from their original position and move to the interstitial site. So Frankel defect is also known as dislocation defect, where a cation is missing from its position, where a cation is dislocated from its position to the interstitial site. So this is a correct statement. Let us see option C. Frankel defect is usually favored by very small difference in the sizes of cations and anions. No. This is a condition for, Schottky defect. In case of Frankel defect, student, the difference between the sizes of cation and anion should be large. Cation should be very small and the anion should be large, and there is a large difference in the size of cation and anion. So this is a wrong statement. Schottky defect has no effect on the physical properties of solids. Students, here, Schottky defect means, what is Schottky defect? Cation is missing from the lattice site and the anion is also missing from the lattice site. Suppose if you think these are cations and anions, equal number of cation and anion both are missing from the lattice site. If both are missing from the lattice site, then the density should decrease. The density should decrease. That means physical property is affected. So this is also not a right statement. So only correct statement is Frankel defect is a dislocation defect. Okay, go to the next one. Sodium metal crystallizes in BCC lattice with edge length of 4.29 angstrom. The radius of sodium atom is option A 1.857 angstrom, option B 2.145 angstrom, option C 1.601 angstrom is 2.857 angstrom. So you have to find out the radius. Edge length is given, but you need to find out the radius. Students, whenever such question is asked, you should be ready with the formula. See this three formulas. Now in this question, the question is about BCC. But it need not be every time for BCC. That is why all the formulas I have written together. In case for a simple cube, edge length is given and the radius is asked, then the relation is A is equal to 2R. Remember, if it is for BCC, A is equal to 4R by root 3. And for FCC, A is equal to 2 into root 2R. And also remember the root values and keep it ready. At least, these which are required so that directly you can solve the problem. Now, present problem has BCC, radius is asked, edge length is given. So, the formula is root 3a by 4. So, we will solve the problem, student. And what is the formula? Formula is equal to root 3 into a by 4. Root 3 is 1.73. In case if you do not remember also, you know that root 4 is 2. If it is root 4, it is 2. So root 3 means it will be somewhere in 1.7, 1.8 like that. So 1.73. Edge length is given as 4.29. Divide by 4. So students, you can very clearly, you need not get into the last part of the problem. You can see here, right? This is 4 ones are, right? It cannot be 2.857 because you are going to multiply by 1.0 something, right? With 1.73. It cannot be 1.601 because it is larger than that. It cannot be 2.145. So the possible answer is only 1.857 angstrom. Otherwise, you can multiply and see. So sometimes students, you need not, entire problem you need not solve. We'll come to know what is the right answer because there is a lot of difference from the right answer to the other answer. So option A is the right one. Go to the next one. Schottky defect is observed when? Option A, an ion leaves its normal site and occupies an interstitial site. Unequal number of cations and anions are missing from the lattice site. No ion missing from lattice site. Equal number of cations and anions are missing from the lattice. So students, as you can see here, Schottky defect is observed in. Now I have already taught you what is Schottky and what is Frankel. But for recap, once again, let me show the diagram. Schottky means equal number of cation. This is cation, student. This is anion. Equal number of cation and anion is missing. Frankel means the smallest ion. The cation is missing and goes to the interstitial position and occupies it. So since it is about Schottky, it is equal number. In order to maintain electrical neutrality, student, equal number of cation and anion are missing from the lattice site. That means our answer should be D. Option D is the right answer. So students, remember, from the defects, questions are asked in the previous exam for CET exam. So do not think of leaving anything, especially when you prepare for a competitive level exam. Study the entire NCERT book carefully so that you are, able to solve questions from any side. So we will go to the next one. In a face-centered cubic arrangement of A and B atoms, in which A atoms occupy the corners of the unit cell and B atoms are at the face center. One of the atom A is missing from one corner in a unit cell. The simplest formula of the compound is. So if you want, you can read once again the problem. Meanwhile, let me solve, this. We will draw one cube and we will try to solve it. Okay. Now, if you can see here, FCC is given. It is said that B atoms, A atoms are at the corner, B are at the face. So when I say B are at the face, how many faces a cube has? We all know that there are 6 faces. That means there are 6 B particles. Agree, student? There are 6 B particles. And whenever a particle is at the face center, what is the contribution, student? I have taught you in the first equation. It is half. When a particle is at the center of the face, its contribution is half. Apart from that, we also have a particle at the corner of a cube. Now, how many corners you have in a cube? You have 8 corners. But it is said that one of the corner is missing. That means only I have 7 A atoms. One corner it is missing. And whenever a particle is at the corner, its contribution is 1 by 8. Correct? Contribution is 1 by 8. Therefore, it will be 7A by 8. Right? And it will be 3B. Or it will be 7A and 24B. Correct? So, A4, A7 and B to A7 and B24. So the answer will be option D. So students, I hope you have understood. In case if you have any questions, write it in the comment box. Okay. See to it that you are clarifying all your doubts. In case if you have a kindly write it in the chat box so that we'll come to know in case if you have any questions related to this topic. We'll go to the next one. In FCC, the unit cell is shared equally by how many unit cells? In FCC, the unit cell is shared equally by how many unit cell? Students, in FCC, if you consider, in any unit cell, student, how many unit cells are sharing it? Now look here, See, you have, this is one unit cell. I hope I'm making it. I will just darken that place. See, this is one unit cell. So when I say one unit cell, how many unit cells are sharing it? So if you have a unit cell here, 1, you can have one more unit cell here on this side, 2, correct? Right? So on this side you will have 3 and you will have 4. See, the question is now, I hope you try to understand the question. It is not the particle that is asked, it is in FCC, the unit cell is shared by how many unit cell? Students, in a unit cell when you take, it's a cube like this, you think. This is one unit cell. One unit cell has how many faces now? When I say face-centered cubic lattice, there are 6 faces. Correct? It's a cubic lattice, so 6 faces. So when I say 6 faces, there will be 6 unit cells, student. 1 on this side, 2 on this, 3, 4, 5, like that. 6 I have, 1 above. Are you getting it? So there will be 6 unit cells which are shared cell. Therefore, the answer will be, student, 6. Whether it is BCC or a simple cube, each unit cell will be shared by 6 unit cell. Okay. Edge length of a cube is 300 picometer. Edge length is given. The body diagonal would be. So, edge length of a cube and the body diagonal is asked. Now we know that the body diagonal is equal to √3. So students, remember that you will be noting down all the formulas. So the body diagonal is equal to √3 into A. √3 is equal to 1.73 and A is 300 picometer. Okay, once again, it is not 600 because it's not 2 here. It cannot be 423 because it is 1 very close to 2. So possible answer is 519.6. Otherwise, you multiply and find out. So answer will be option C, 519.6. Okay. We'll go to the next one. The ratio of cationic radius in an ionic crystal is greater than 0.732. Its coordination number is. Students, when you prepare yourself for competitive level exam, you also remember this table. Okay. Now this is a table which will give you the radius ratio value. Now what is the radius ratio value? Radius ratio value means, what is radius ratio? It is a ratio of radius of the cation to the radius of anion. And this radius ratio value, student, this is a range. This is a range. This will be the coordination number and this will be the structure. If the radius ratio is lesser than 0.155, it's a linear structure with a coordination number 2. If the radius ratio is 0.225 to 0.155, this range, then it's a triangular and the coordination number is 3. If this is a range, then coordination number is 4 with a tetrahedral geometry. If it is between 0.414 to 0.732, then the coordination number is 6 and it's an octahedral structure. More than 0.732 up till 1, it's a cubic structure. Okay. So look at the question now that has been asked. The ratio of cationic to anionic radius of an ionic crystal is greater than 0.732. Greater than 0.732 means it falls under this region. This is in between. This is greater. 0.732 to 1. Therefore, coordination number is 8. It's a cubic structure. So, answer should be option D. So, thank you students. Thank you for attending the class. You will have my next YouTube session on 5th exactly at 2 o'clock. Kindly see to it that you will be attending or joining me exactly at 2 o'clock on 5th of January. And also students, kindly watch on my previous YouTube session. In case if you like the class, kindly press the like button and do not forget to share and subscribe.